Hello everyone and welcome to the Engineers Gateway. I welcome you all to this platform. Today we are going to see some really interesting questions from different particular topics of mechanical engineering. And if you have not gone through the previous videos, you can follow the link here. And if you are new to the channel, please consider subscribing. And let us just begin with the first problem from electrochemical machining from manufacturing engineering. Okay, so the question is something like this. You are given that electrochemical machining is taking place with tungsten as the electrode and copper and aluminium as the work materials. You are given that for copper atomic weight is 63 and for aluminium same thing, that is atomic weight is given as 27. For copper you are given that the valency is 2 and the same for aluminium is 3. Okay, for copper the density is given as 9 grams per cc, and for aluminium you are given the density as 2.7 gram per cc. Okay, you are given that copper has a material removal rate material removal rate of 100 grams per cc, and you are supposed to find the material removal rate for aluminium in grams per cc considering all other parameters remain unchanged. Okay, all other parameters remain unchanged and you are supposed to find now. How do we proceed? First look at the question, what you are given. It looks simple, and at a glance if we see, we know that MRR in electrochemical machining is given by AI upon rho V F, where I is current, F is in whatever, F is a constant. Okay, now we are given atomic weight, we are given density, we are given the valency for both the materials. Can we say that the unknown quantities I and F, they will remain constant? Can we say that? Isn't it? So what we will get is MRR for C U copper is equal to A, and similarly for aluminium MRR will be similar. So what we will get is MRR copper into rho copper into valency copper upon atomic weight copper is equal to MRR aluminium into rho aluminium into valency aluminium whole divided by atomic weight aluminium. Okay, this is what most of the students do, and even I had done the similar kind of mistake while I was solving the problem. The problem with us is we see the question, we remember the formula, and then we just begin to solve the problem without ever thinking what the problem is actually asking. The formula which we have written over here is not the formula for grams per cc. The formula MRR is equal to AI upon rho into valency into Faraday's constant. This is valid for cm cube per second. Okay. Okay. And you have been asked in gram per second. Okay. So how do we proceed? We know that MRR is equal to cm cube per second. Okay, this is the formula we know. And how to convert that into our gram per cc? If we know, if we multiply it by gram per cc, that is nothing but cm cube per second into rho. Isn't this? Okay, so what happens is when we multiply this by rho, in this particular formula, MRR, if we multiply it by rho, this rho will get eliminated. So in this particular case, while we are equating I by F as a constant, we do not need these two. And so, likewise, this data becomes an extra data. And because we are always obsessed with using the formulas directly, we tend to start solving the problem without any intuition that the problem setter or question setter is actually trying to bluff us or trick us. Okay? Even I had done similar problem, and I had failed to answer such question in the examination while I was trying to give the exam. So this is something that we need to learn eventually as we grow and evolve as engineers. Okay, that we need to value the concepts as well as we need to value the units. Okay, so let us move. Now when we solve it, what we will get is MRR aluminium will be nothing but MRR copper into atomic weight aluminium into valency copper upon atomic weight copper into valency aluminium. Okay, when we put the values, what we will get is 100, because everything is in gram per cc. So atomic weight of aluminium is given as 27 into valency of copper given as 2 into atomic weight of divided by atomic weight of copper given as 63 and valency of aluminum given as 3. Okay, 9 7, okay, sorry, 9 7, and what we get is MRR aluminium is nothing but 200 by 7. Okay, and it comes out to be somewhere around 28.5 in gram per second. Okay, so units are very much important, and as we evolve or we try to solve questions regularly, what we will understand is that it's highly important to value the units as well as the concepts as well as the formulas which we are going to use, the conditions in which the formulas are applicable. Okay, now we will move on to the next question shortly. Thanks for viewing. Welcome back everyone. Now we will see a classic question from engineering mechanics which was asked in GATE 2022, and many students left the question thinking that it's very complicated, but that is not actually the case. When we see the question, we start feeling that it is a question of slippage and we start to feel that it's difficult. But when we try to apply the concepts, we will realize that the things are not as complicated as they seem. Okay, see the question. You are given a disk, okay, of mass m, radius r, and it is spinning freely with an angular velocity omega. This disk is just above surface of a rough plane with coefficient of friction mu. Okay, now what you are asked is, after this disk is released on this rough surface, what will happen? It will initially try to slip. Okay, but eventually it will gain some velocity, linear velocity, and it will lose its kinetic energy, and it will try to continue pure rolling. So after what time t will this start pure rolling? Okay, I hope the question is clear. Okay, how to proceed this question? You are given angular velocity omega, you are given mass m, you are given radius r. Okay, we know that for a spinning disk, moment of inertia will be given by mr square by 2. Also, we know that due to friction over here, you have to carefully see the direction of friction I have used. It is backward and not forward, because when there is slippage, the direction of friction will be backwards and not forwards, whereas in case of pure rolling, friction acts in forward direction. Okay, so in this case, this friction F acting at a distance r is going to create a negative torque. Okay, so this torque is going to decelerate the, okay, on the surface this is acting here, but on the disk it will be acting like this, reactive force of friction. What that will do is it will try to decelerate the angular velocity, but at the same time this reactive force will generate an angular deceleration alpha, and this alpha will try to increase the velocity in this direction by applying a linear acceleration a. Okay, so can we say linear acceleration is a equal to alpha into r? Fine, and the torque is given by F into r is equal to tau, which is also equal to I into alpha. Excuse me for a moment. I'm sorry, there was a call. Okay. Now this I into alpha is equal to a by r, or a is equal to alpha into r. Okay. Now this force of friction will be given by mu into the weight, that is m into g into r, is equal to mr square by 2 into alpha. So this r square and r, m and m get cancelled. What we are left is alpha is nothing but equal to 2 mu g by r. Fine. And as we know, alpha into r is equal to a, so linear acceleration a is nothing but equal to 2 mu g. Okay. Now again look at the problem. As this disk will start decelerating in angular velocity, so what we will get is alpha is equal to omega minus omega dash by t. Fine. And also a is equal to v minus 0 by t. Why is it a 0? Because initially the linear velocity in this particular direction was 0, and omega dash is the angular velocity after time t, which it will achieve upon pure rolling. Okay, so omega dash is nothing but v by r. Isn't this the case? What we will do is we will just replace omega dash by v by r, and what we get here is t is equal to, let me solve it. For this particular equation, acceleration was 2 mu g is equal to v by t. This gives us v is equal to 2 mu g into t, or t is equal to v by 2 mu g. We will see it considering what equation we need to use. And in this particular equation, if I replace alpha and omega dash by v and v by r, what we get is alpha is equal to 2 mu g by r. So what we get is 2 mu g by r into t is equal to omega minus v by r. Okay, multiplying by r we get omega r over here, this r gets cancelled. Fine. So we had this equation, t is equal to v by 2 mu g, and we have this equation. So if we replace this v in terms of t, we can solve it for t. So let us do it, and let's see what we get. This will give us 2 mu g into t is equal to omega into r minus 2 mu g into t. Fine. So now taking this over this side, we get 4 mu g t is equal to omega r. So t will be equal to omega into r upon 4 mu g. This is what we have been looking for. Also, if they had asked you about velocity, if you replace this t on that particular velocity, this equation, what you get is v is equal to 2 mu g into omega r upon 4 mu g. This mu g gets cancelled, these two gets cancelled with 4. We are left with this, so we get omega into r by 2. Also, if you were asked omega dash, okay, these are the variations of this particular question that can be found. Okay, so omega dash was equal to v by r, so we have the v omega r by 2. So omega into r by 2 into 1 by r. R gets cancelled and we are left with omega by 2. Fine. So I hope this question is clear to everyone. Please go through the questions once again and we will meet in the next problem. Thank you so much.